16% was 4.81, and the 66% was 4.62. And after filtering it through the 4 different filters, we got the numbers in the middle pH column. And the last column shows the change in the pH from before and after the filtration. And we can see here that the hydrophilic filter was consistently the most efficient for both concentrations. So we came to a conclusion that the hydrophilic filter, the filtered solution for the hydrophilic filter was closest to neutral pH, which is 7, and it filtered out the most Roundup, which shows that our hypothesis was only partially correct because we hypothesized that the hydrophilic filter with nanoparticles would be the most efficient. And from this bar graph of the pH of resulting solutions, we can see that there's a pattern. So the hydrophilic was consistently the most efficient for both concentrations. So some possible errors that we might have had is pH measurements. Because it took such a long time to filter out the solutions, we only had a small sample size and we're not able to use the pH meter. So we used the pH paper, which might not be as effective. And also when we used the pH meter for one of the solutions, we saw that the numbers we got were kind of different, so that could have been a possible error. Also, we could have incorrect functionalization, but we would not know because we did not test the wettability of the filters. So some future directions could be having more time to filter more solutions so we could use the pH meter, and using all the different concentrations instead of the two extremes, and also measuring the contact angle of the filters to see if they have the correct wettability that we desire. Thank you. Any questions?
Thank you. That was an excellent presentation. Did you look ahead to see how you might use this for filtering large amounts of water like groundwater, where pesticides and pollutants are a significant environmental problem?
So yes, that is the major application of what we were studying. So currently it's proven that activated carbon does help with the filtration process of glyphosate along with different other pesticides. But we were testing to see if there was a more efficient filter design that we could use wettability properties, just make the process more efficient and effective.
Any other questions?
So did you time how fast the different filters went?
We were going to, but then we thought that would be too many variables. But we saw that the hydrophilic was the fastest. We got through both of the concentrations before the other filters got through the first concentration.
And so how do you interpret that? In terms of the earlier question about actually using this for real groundwater remediation, how is that result important?
Well, the hydrophilic filter, as you can see, was the most efficient. It got most of the Roundup out, and it was also the fastest. It was the fastest time for getting rid of the Roundup, and also it was closest to neutral pH. So if we were to filter out a larger amount of Roundup in the real world, then we would use the hydrophilic filter.
Yeah, there are lots of good filters that work, but most of them are just way too slow for real water treatment. So speed is a super important variable. Okay, good.